Okay, hello everyone. Welcome to CES 2208 Information Storage and Management 1. My name is Alejandro Arbeláez and I will be your lecturer this semester. This year, as you know, given the current situation, the teaching experience is going to be a little bit different. It's going to be mainly this module is going to be mainly online. Okay, and we're going to have one of the lectures is going to be synchronous live lecture, so we will be able to interact a little bit, and the other lecture is going to be asynchronous, and I will try my best to provide the material of the lecture that is not live before the indicated timetable, okay, so that you can use your time for your original time for looking at the lecture material. Okay, so basically here we go. Okay, so this is my picture in case you haven't seen my face. Okay, so basically I'm one of the lecturers in the computer science department, and I have a number of years of teaching experience, mainly teaching in computer science and also in the area of data science and analytics. Actually, my PhD is in the intersection between computer science and data science analytics. I also have a number of years of postdoctoral experience, postdoctoral researcher experience. I will be talking a little bit about this in a couple of minutes. And I did my PhD in computer science. I also have an engineering degree in computer science. If you want to contact me, you can contact me in this email address. However, you can certainly contact me in this email address. However, I strongly recommend that if you have any question about the labs, or any question about the material, or any particular question about the module, the course, I strongly recommend that you use Canvas. Why? I'm not going to reply individual emails about the particular topics. Okay, because the idea is that you are going to formulate your questions in Canvas, and then I will reply that for everyone. So in case that another student is going to have the same question or a similar question, so we all benefit, all the students benefit of my answers. Okay, I will talk a little bit about that in a minute. Okay, so something a little bit about myself. 1 second. Probably some of you think that I'm from Spain, but actually no, I'm not from Spain. I'm from Colombia, from this beautiful country in South America. It's Colombia. It's not Columbia. It's actually pronounced Colombia. And actually I'm also Irish. I got my Irish citizenship a few months ago, so I have both citizenships. Okay, so basically I started teaching in UCC in 2019, so it's a little bit more than 1 year. But before, I was teaching in CIT. I was teaching similar modules. I was teaching mainly in the Master in Artificial Intelligence, also in the Data Science and Analytics, and also I was a program coordinator there in the Software Development Program, which is in computer science. Before that, I was a postdoc in the Insight Center of Data Analytics here in UCC, in the second floor, and I was working in projects related in the area of data science and analytics. Okay, some of those projects involve machine learning and optimization, but I'm not going into all the details. Before that, I was in Tokyo. I did another postdoc in the University of Tokyo. I was working in a French and Japanese lab, so I was working with people from French and Japanese researchers, and I was working basically using artificial intelligence for parallel computing. Okay, this parallel computing was a little bit different than the parallel computing that we have in a regular computer. In a regular computer we have, let's say, 8 processing units, but in this kind of computing environment that I was using was massive supercomputers, so basically using thousands of processing units, so it's a little bit different. We will be seeing actually a little bit of parallel computing in the second part of this module in the second semester in CS 2209, but that's in the second semester. And I did my PhD in France, so as you can see, quite a lot of traveling. So I'm from Colombia, then I went to France, and then I went to Tokyo, and now I'm in Ireland. And I was working in the intersection between what I call predictive and prescriptive analytics. So basically the use of machine learning and optimizing decisions. But I'm not really going into a lot of details of this at this point. The idea of today is just to give a quick introduction of myself, of the module, and I'm not really going to cover new material today. Okay, in this particular module, I strongly recommend that you have a look at the module descriptor, but in this particular module we are going to be talking about the design of relational databases. Okay, so basically last year you were studying a little bit about relational databases, so at this point I'm expecting that you are familiar with relational databases, with SQL. You can create tables, you can write your queries, and so on and so forth. Okay, and in this module we're going to be talking a little bit, we're going to focus more in the design, okay, designing a proper design of a database and optimizing those queries and so on and so forth. Okay, so basically we are going to go into a little bit more detail of SQL, so what is behind SQL, the formal definition of SQL. So that's called relational algebra, relational calculus, which is the formal foundations of SQL. A little bit of real applications and so on. Okay, so basically this is the module descriptor. I strongly recommend that you go into the module descriptor and have a look at the content. Okay, today I'm going to quickly describe this module descriptor, but I strongly recommend that you go there and have a look at all the details. We are going to have one formal exam at the end of the semester. This is going to be 80% of the module, and then we are going to have 20% of continuous assessments. I'll be talking about this in a minute. Now, again, given the current situation, this might change. We are trying our best to keep this as indicated in this module descriptor, but given the current situation, this could be changing. We are not going to be changing the content and the learning outcomes, but the evaluation might change. Okay, but if something changes, I will let you know well in advance. I'm expecting that this is not going to change, but I just wanted to let you know. Okay, so I strongly recommend that you have a look at the description of the module. Okay. As I said before, we are going to have 2 hours of lecture every week. 1 hour is going to be synchronous live, and the second hour is going to be asynchronous. And again, I will try my best to provide the material of the lecture that is not live before the indicating timetable, as indicated in the timetable, so you can use that time in order to study the lecture material. And we are also going to have 1 hour of lab, and we're going to have 10 labs as indicated in the module descriptor. Now I will try to also provide solutions for the labs, so 1 week after. Sometimes I might not provide solution because it might be relevant to the assignment. Okay, but I will try, if possible, I will try to provide my solutions, but that doesn't mean that my advice is that you have try to solve the lab yourself. Okay, so don't wait until I provide the solutions, because it's not really the same. Okay, it's better that you try to find the solutions. If you have any questions, you let me know, and I will try to help as much as possible. We are going to have the continuous assessment part. We are going to have 1 interactive Canvas exam, and that's going to be in week 6, and we are going to have a project assignment, which is going to be at the end of the semester. I will provide more details about, because we have to potential dates for week 6. I will let you know exactly when in week 6 we are going to have the interactive Canvas exams. We are going to be using Canvas quizzes for this. And the second project assignment is going to be a practical project about what we cover in the module, and then we have a written exam that is 80% of the module. Now for Canvas, I strongly recommend that you use the discussion board. Okay, so if you go into Canvas, in the module in Canvas, you will see that there is a discussions, and then in discussions you formulate your question. Okay, so and then I will try to check that on regular basis, and I will try to reply as soon as possible, or even other students can provide solutions. Okay, but I will be trying to check Canvas as much as possible. Don't expect a reply in hours or something like that. So it might take a couple of days, a day or two to reply. Okay, but please use that in order to communicate as a general for any general question about the module. Now this is something really important. I'm quite sure we are not going to have any issue with this. 1 second here. I'm quite sure we're not going to have any question or any problem about this, but this is something that I have to tell you. Basically, any evaluation that we have, and then you submit, everything must be your own work. Okay, so you need to be sure about that. You need to submit your own work, that you are not taking portions of the solutions from other sources. Okay, so it must be your own work. I strongly recommend that you read the policy, the UCC policy and regulations, because this is going to apply for everything. For example, we're going to have one interactive Canvas exam, and we also have a project, and you have to submit your SQL code. Okay, so basically this is applying for both. I'm sure that we're not going to have any problem, but anyway, I have to let you know about this. And sometimes you might use portions of the code that I provide, but if I don't say that you can use any particular portion of code, you have to you can certainly ask. Okay, and this is not only for me, you can ask for any other lectures, any other modules. If you are not sure if you can use something for your assignment, project, or any evaluation, check with your lecturer, and we will be happy to clarify anything. Okay, so please check before if you are not sure. Okay, so generally speaking, this is what we're going to be covering during the semester. Just give me 1 second. Basically, this is what we're going to be covering during the semester. We're going to be starting with general at the very beginning. So basically this week and probably a little bit of next week, we're going to be covering basic SQL. So just to quickly recap the structure of SQL, how to write tables and joins, because that's going to be relevant for the next couple of lectures. We're going to be talking a little bit about primary keys, foreign keys, and so on and so forth. And then we're going to be spending quite some time about the database, modeling databases, proper modeling of databases. We're going to be seeing the entity relationship diagrams, normal forms. We're going to be talking about the first normal form, second normal form, and so on and so forth. And then the foundations of the query language, which is called relational algebra and relational calculus. And then we will see how to optimize a query. Okay, for example, if you have to write a SQL query, there are lots of ways of writing that query, but we will be seeing that depending on how we translate that query in the relational algebra, for example, one query is going to be more efficient or less efficient depending on how you search in the tables. Okay, it's going to take more, or it's going to be taking less time, or expecting to take less time. For example, something that is very important is to use an index. That's going to be improving the time that we need in order to perform a query. Okay, so that's the improvement could be quite a lot for searching, okay, for querying. Now if we have an index, that might have an impact, so it's going to be faster to get the data, but we might have to introduce additional data structures, and it might be slower. It might take more time to insert or to delete information from the database. So we have to play with this balance. Okay, so faster depending on what you want to do in your database. If you have to query a lot, it's a very good idea to have an index, but if you have to insert or delete a lot of data, probably it's better to do something else. We are also going to be talking a little bit about views, triggers, and so on and so forth. I call this a little bit of advanced SQL, but we will be talking about this this is just a general view. Again, everything is in the module descriptor, and if you have you can go there and check everything in detail. These are some of the books that I recommend for this module. These are two very good books about related to the module. You can have a look at this if you want. However, you have to be careful that sometimes the notation, in particular for the entity relationship diagrams, is changing from one book to the other one. So you have to be sure that you are studying the notation that I use. For example, I use the chain notation, so for that particular topic. So you have to be careful to see which one is covering that particular point. Actually, I'm using material from these books for the lectures as well. Okay, so what is a database? Basically, a database is just a collection of files. At the end, it's just a collection of files that we use in order to store data. Okay, so that's at the end that we store information in the computer, and at the end that's going to be stored in files. Okay, these are some examples of databases. For example, the payroll database, so we have the information of when we are paying, the staff, the amount of money that is being paid for the staff. That's one of the databases. Typically, this is a relational database. Now we have a lot of NoSQL databases, which is also very popular. But that's for at least we're going to cover non-relational databases in the second semester. This semester we are going to focus in relational databases. For example, the students database, that's another very popular example of the students database. So we're going to have, for example, we have one table for the student data, one table for the modules that we have in the university, and so on and so forth. The Amazon, the products that we have in Amazon, that's another very popular example of a database. Airline reservation databases, another very popular. Well, actually, one of the first popular databases was for airline reservations. I think it was American Airlines. I'm not quite sure at this moment, that they have a very popular database a long time ago. Okay, so but at the very end, database management system is just a program. We are not going to write that program. Just give me 1 second and move this. It's just a program that another person, a team actually is writing that program, and they are writing that in a it's very efficient. Okay, so don't try to write your own database, okay, your own program for the database, because there is a lot of very efficient databases, and they do a very good job for that. Okay, so we are basically going to interact with the database using SQL. That's probably the most popular query language for interacting with relational databases. Actually, if you learn SQL, you will be able to use almost any relational database, because the changes are just tiny. If you go, for example, from MySQL to the Microsoft database or something like that, SQL is the same, just mainly tiny changes. Okay, there are lots and lots of databases. This one is a very popular one. It's a very popular commercial database. Microsoft SQL Server is also quite popular. These are you have to get a license for using these commercial databases, but you also have open source databases. MySQL is one of the most popular open source databases that we have. It's quite good. It's very robust, works very good. And we have Postgres. We have a lot. So basically, the relational databases, we have a lot of commercial databases. We have a lot of open source databases. You can even, if you want, you can even go into the code and you can modify that yourself. I strongly don't recommend that you modify the code of a database because that's extremely complex. They use very complex data structures. Some of those data structures, we are going to be talking about those data structures in this semester and probably in the next semester as well. And we also have open source libraries. SQLite is a very good, actually SQLite is now becoming quite popular. Okay, this is something very nice because the database is just a file, okay, and a program, and then if you want to move a database from one computer to another one, all you have to do is to take the file and copy that file into the other computer. Okay, now there are a lot of security issues with that, but it's quite popular for small projects. I've been using this I used that a while ago for a project that I was doing. It works quite good. Now this is for small databases. There are a lot of issues about using this library. Probably would be better for a medium size or big projects that you go with one of the big ones. Okay, MySQL, Postgres, or if you are involved in a huge project, probably would be better to go for one of these commercial databases. They provide a lot of support for that. Sometimes open source means that you can use it for free, but sometimes you get a lot of problems, and if it's an open source database, you don't get support, and at the end it might be even more expensive to try to solve the problems than to get a commercial database. At the end, it depends on the project that you are involved. Again, in this semester we are going to be talking mainly about relational databases and database management for relational databases. Next semester we are going to be moving a little bit to NoSQL databases, and this semester we are going to be using mainly MySQL. That's the idea, and probably the environment is going to be similar than the one that you used last year.